Let's dive into an exciting cosmic scenario. What if a nearby star became a hypernova? Imagine you're sitting in your backyard, gazing at the night sky, when suddenly one of those twinkling stars explodes with unimaginable power. That's what we're exploring today. First, let's break down what a hypernova is. You've probably heard of supernovas, right? Well, a hypernova is like a supernova's bigger, badder cousin. It's an extremely energetic stellar explosion that occurs when a massive star, typically more than 30 times the mass of our Sun, collapses at the end of its life. Now, let's set the stage. Our Milky Way galaxy is home to billions of stars, and some of them are close enough to be considered nearby in cosmic terms. For our scenario, let's imagine that a star about 30 light-years away from Earth suddenly goes hypernova. That's pretty close in astronomical terms, just a stone's throw away in our vast galaxy. So, what would happen if this nearby star exploded in such a dramatic fashion? Let's break it down step by step. 1. The initial blast. When our nearby star goes hypernova, it would release an enormous amount of energy. We're talking about more energy than our Sun will produce in its entire 10 billion-year lifetime, all unleashed in a matter of seconds. This explosion would be so bright that it would outshine entire galaxies. If you were looking up at the night sky when it happened, you'd see a brilliant flash of light, brighter than anything you've ever seen before. It would be visible even during the day, appearing as a second sun in the sky. 2. Radiation burst. Along with the visible light, the hypernova would release a massive burst of high-energy radiation, including gamma rays and X-rays. This intense radiation would travel through space at the speed of light, reaching Earth in about 30 years. Remember, our hypothetical star is 30 light-years away. When this radiation hits Earth's atmosphere, it would cause some pretty wild effects. The upper layers of our atmosphere would become ionized, potentially disrupting radio communications and satellite operations. The sky might light up with spectacular auroras visible even from the equator. Imagine seeing the northern lights from the beaches of Hawaii. 3. Cosmic ray bombardment. Following the initial radiation burst, Earth would be bombarded by high-energy particles called cosmic rays. These particles, accelerated to nearly the speed of light by the hypernova explosion, would continue to arrive for thousands of years after the initial blast. While Earth's magnetic field and atmosphere protect us from most cosmic rays, this increased bombardment could have some long-term effects. It might lead to an increase in mutation rates in living organisms, potentially speeding up evolution, though not in a controllable or necessarily beneficial way. It could also increase the risk of radiation exposure for astronauts in space and passengers on high-altitude flights. 4. Ozone layer depletion. The intense radiation from the hypernova could potentially damage Earth's ozone layer. The ozone layer is crucial for protecting life on Earth from harmful ultraviolet, UV, radiation from the Sun. If it were significantly depleted, we'd see an increase in UV radiation reaching the Earth's surface. This could lead to higher rates of skin cancer, damage to plants, and disruption of marine ecosystems. However, it's important to note that our atmosphere is pretty good at regenerating ozone, so this effect might not be permanent. Still, it could take years or even decades for the ozone layer to fully recover. 5. Climate effects. The energy from a nearby hypernova could potentially affect Earth's climate. Some scientists suggest that the cosmic ray bombardment could increase cloud formation, potentially leading to global cooling. This is because cosmic rays can ionize molecules in the atmosphere, which can then act as seeds for cloud formation. On the flip side, if the hypernova were to destroy a significant portion of our ozone layer, it could lead to warming, as ozone is a greenhouse gas. The balance between these cooling and warming effects would depend on the specific characteristics of the hypernova and its exact distance from Earth. 6. Biological impact. The combination of increased radiation, potential climate changes, and ozone depletion could have significant impacts on Earth's ecosystems. Some species might be more affected than others. For example, plants and animals that are more sensitive to UV radiation might struggle, while those that are more resistant could gain an evolutionary advantage. In the oceans, increased UV radiation could harm phytoplankton, the tiny organisms at the base of many marine food chains. This could have ripple effects throughout marine ecosystems and potentially affect global fish stocks. 7. Gravitational waves. A hypernova would also produce gravitational waves, ripples in the fabric of space-time. While these wouldn't pose any direct threat to Earth, they would be detectable by our gravitational wave observatories. This would provide scientists with valuable data about the nature of hypernovas and the extreme physics involved in these events. 8. Neutrino shower. Along with all the other forms of energy, a hypernova would release an enormous number of neutrinos. Neutrinos are tiny, nearly massless particles that rarely interact with normal matter. Trillions of them pass through your body every second without you noticing. In the case of a nearby hypernova, the neutrino flux would be so intense that we might actually be able to detect it. In fact, the neutrinos would arrive before the visible light from the explosion, potentially giving us a few hours of advance warning before the main light show begins. 9. Long-term stellar neighborhood changes. After the hypernova, our stellar neighborhood would be forever changed. Where once there was a massive star, there would now be either a black hole or a neutron star, depending on the original star's mass. The explosion would also spread heavy elements throughout space, potentially seeding future generations of stars and planets with the building blocks of life. 10. Impact on human society. The effects of a nearby hypernova wouldn't just be physical, they'd have profound implications for human society too. The sudden appearance of an incredibly bright new star in the sky would likely cause widespread awe, fear, and speculation. Religious and cultural interpretations of the event would vary widely around the world. The potential disruption to communication satellites could cause significant problems for our increasingly connected global society. Navigation systems, weather forecasting, and global communications could all be affected. If the hypernova had significant climate effects, we might see changes in agricultural patterns, potentially leading to food shortages in some areas and surpluses in others. This could lead to large-scale human migrations and economic disruptions. On the positive side, such an event would likely lead to a surge of interest in astronomy and space science. It would provide scientists with an unprecedented opportunity to study these rare cosmic events up close, potentially leading to new discoveries and advancements in our understanding of the universe. 11. Technological considerations. Our modern technology would face some unique challenges in the face of a nearby hypernova. The intense electromagnetic pulse, EMP, from the initial explosion could potentially damage electronic systems on Earth, especially satellites and power grids. This could lead to widespread power outages and communication disruptions. On the other hand, the advance warning provided by neutrino detectors could give us time to prepare and protect sensitive systems. This event would likely spur the development of new technologies designed to shield against cosmic radiation and EMPs. 12. Long-term cosmic perspective. While a nearby hypernova would be a catastrophic event in many ways, it's important to remember that such events are a natural part of cosmic evolution. The heavy elements that make up our planet, including the iron in our blood and the calcium in our bones, were forged in the hearts of massive stars and scattered across the cosmos by supernovas and hypernovas. In a sense, we are all made of stardust, and events like this are part of the grand cycle of matter and energy in the universe. A nearby hypernova, while potentially disruptive or even dangerous to life on Earth, would also be a reminder of our connection to the cosmos and the incredible forces that shaped our existence. In conclusion, a hypernova occurring near Earth would be an extraordinary and potentially catastrophic event. It would pose significant challenges to life on Earth, from increased radiation to potential climate effects. However, it would also provide an unparalleled opportunity for scientific discovery and might even spur technological advancements as we adapt to deal with its effects. The good news is that stars capable of going hypernova are extremely rare, and none are currently close enough to Earth to pose a significant threat. The nearest star that might eventually go hypernova is probably Eta Carinae, which is about 7,500 light-years away, far enough that we'd be relatively safe from its effects. Nevertheless, studying these cosmic possibilities helps us better understand our place in the universe and the forces that shape it. It reminds us of the incredible cosmic journey that led to our existence and the ongoing drama of the stars that continues to unfold in the night sky above us. So the next time you look up at the stars, remember, you're watching a cosmic story billions of years in the making, with plot twists like hypernovas that are beyond our wildest imagination.